Okay, class, this is going to be Light Optics Vision 2. So we previously talked about the pathway of light entering the eye, going through the cornea, needing to be refracted, going through several layers. And we spoke of that with the cornea having the most refracting power, but again, the lens can change shape, so it can change the refracting power to see far off or close. We also mentioned that the sympathetic nervous system was the one producing norepinephrine that would cause the vision to be able to be seen far off. And the parasympathetic nervous system was the one to see close up because of certain changes that occur. So again, when you're looking at close up, you would like the pupil to be constricted to keep aberrant light away. You would like the lens to be thickened, and the way to do that is to contract the ciliary muscle to thicken the lens so the focal point can be the proper location. All of that, so the sympathetic nervous system is handling distance and the parasympathetic nervous system is handling close up. But the other thing, we have two eyes, and they're in front of our head versus on the side of our head with some animals. So we have a binocular vision. So one of the things we also want to do when we're looking is to have the same focal point. So if we're looking at something close up, the eyes will come in. All of this is happening through the oculomotor nerve. Oculomotor nerve, remember, has some parasympathetic fibers in it, and it has somatic. The somatic nervous system for skeletal muscle would operate the skeletal muscles, which would be the extraocular muscles that we would have, superior, inferior oblique, lateral rectus, and so forth. So when we're looking close up, we want to bring those two in to give the same focal point, but when we're looking far off, we want them to be straight ahead. Again, oculomotor nerve. So we go further here, which we talked about that. So now we'll speak a moment on, here's the ciliary muscle, a contracted muscle, narrows down there, thickens the lens. The parasympathetic narrows it down, the sympathetic releases it and relaxes it. Okay, now we'll go with problems of refraction, myopia, which is called nearsightedness, and hyperopia, farsightedness, and then emmetropia is normal vision. So when we go to that, let me go here. Here's emmetropia. The light comes in properly, goes to the lens, focals at the right focal plane. Okay. When we look at myopia, the problem is the eyeball is too long. So when the light comes in, it hits in front of the retina rather than on the retina for the image. The way to do that is I need to diverge the light out so that the lens can bend it back in at a sharper angle there. So you have this more concave lens on the inside here that would do that. Again, nearsightedness, eyeball too long. There's myopia again, looking at it, and see there's that lens bending slightly out to bring that focal point there. Okay. When we go to hyperopic, then that's farsighted and the eyeball is too short. So the image focuses behind the retina. The only way to do it is I need to bring it in more. I need to bring it in more, and that would be a nice convex lens there that would bring it in to correct that. So those. Then we go to astigmatism. Astigmatism is a situation where the lens is not curved correctly in all angles, or the cornea is asymmetric. That's an astigmatism that you have. Now, with the astigmatism, let me go here. There again is that. Unequal. So then you get two areas on the retina based upon where the light enters in this asymmetric cornea or retina. Okay. To evaluate that, the optometrist or ophthalmologist has you to look at this and give answers on various questions there that they will ask you. So you're looking at all different angulations. Here's the Snelling Eye Chart, and as you know, I'm sure all of you have had vision check to see what kind of vision you have. And on that particular chart, basically what it is you have the patient stand 20 feet from the chart. You tell the patient to first cover the right eye, then the left, because you want to check both of them, and while the patient covers the right eye, tell the patient to read the lowest line they can read. Repeat this with the other eye. If the patient can read line 8, let's go back. They can read line 8, which would be this, from 20 feet, then they have what we call 20/20 vision. So if the further down you go means the further you can see easily. Okay? That's called, so that's what we're looking at there. There's Myopia again, and we talked about the various eyeballs there. Okay, there's Astigmatism, that defect in the lens or the cornea. All right, we will close here.